हेलो माय डियर मैकेनिकल चैंपियंस, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? प्लीज गाइज डू जॉइन मी फास्ट बिकॉज वी आर गोइंग टू डिस्कस द मोस्ट इंपॉर्टेंट, most complicated questions from the fluid dynamics. We will talk about some questions from the Bernoulli equation and then laminar and turbulent flow in pipe and the compound pipe, multi-pipe system. So those who are watching me live, please do respond me through the comment section if my audio and visual quality are fine, so that we can start this wonderful session on time. So the best 5 questions from the fluid dynamics will be discussed in today's session, which will improve your basics, which will improve your concept of dynamics of the fluid flow, right? This is my quick introduction for those who are seeing me for the very first time. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi. Graduated in 2006. I have also cleared engineering services examination, which is conducted by UPSC. I cleared this exam in 2009. I have worked in Steel Authority of India Limited for a couple of years, and also I have worked in a private consulting firm for more than 2 years. So my total industry exposure is more than 4 years, and the rest of my experience is completely into teaching. I am having more than 10 years of teaching experience, guiding the students who are preparing for various competitive examinations like GATE, ESE and others, PSUs. These are my subjects which I am comfortable with. If anybody is having any doubt in any of the topics mentioned over here, you can connect with me through the mail ID, which is chandra.shekhar7@byju's.com, and it will all be beneficial for you if you join me on the Telegram. My Telegram channel is Mechanical by Chandrasekhar, and the link is also mentioned at the bottom of this screen. All right, because around 1500 students are already part of my Telegram channel. So when you become part of such a group where all the like-minded students are there, you will be able to improve your preparation. Whatever your doubts are, you can share your doubts, you can share your knowledge, and the chances of getting your selection becomes better in your competitive examination. All right, so once you join me on the Telegram, we will provide you the various exam notification. Hi Yashpal, welcome. Good evening, what's up? PDF and notes will also be shared with you. The update of the session, the PDF of this session will also be provided to you through my Telegram channel. All right, and there are doubt clarification, daily important questions will also be discussed through the Telegram channel. Is my audio and visual quality are fine? Please do let me know so that we can start. And there is an important information before we proceed further. There is a workshop going to be conducted on 27th of June, 7:30 p.m. The workshop will be taken by Richa ma'am. She is MTech from NIT Raipur, having more than 5 years of teaching experience in the field of GATE. And she will discuss the best possible strategy for you to be the topper in GATE 2024, to be among the top 1% in the GATE 2024 examination. And the best part is the workshop is completely free. You just have to register yourself, and the link to register yourself for this workshop is already mentioned in the description box. So once, so please go through the description box after your session to know the important links which will help you to boost up your preparation, which will help you to improve your preparation plan, preparation strategy, so that you get the desired success in your exam. Shall we start? Are you all ready to explore this beautiful session? Please make some noise so that we can start our wonderful session of 5 most important questions from the dynamics of the fluid flow. The first question is from the Bernoulli equation. Can you see the question and the diagram? For the given figure, the question is asking you to find out the velocity at the exit. The velocity of flow at the exit. The question is about velocity at the exit. Now, the only concept here is we will use the Bernoulli equation. The only problem here is there are multiple fluids. How to tackle the multiple fluids to get the desired velocity of flow, right? So many students do not know when there are multiple fluids how to apply the Bernoulli equation or the energy conservation equation. If you are able to do that, then you will be able to get the right answer. So we will write our Bernoulli equation, but for applying the Bernoulli equation, the first thing is to select the points between which we will apply the energy conservation. So if you select point 1 here, because we are interested in velocity at 1, so if you select point 1 at the exit of the mouthpiece or at the exit of this tube, then can we say the gauge pressure at 1 is equal to 0? Because it is atmosphere, the fluid is discharged into the atmosphere, so the gauge pressure is equal to 0. If we take this as our reference line, if the horizontal line, the bottom horizontal line is taken as the reference line, do you agree Z1 will also be equal to 0 and V1 is unknown? So the pressure energy at point 1 is 0, the potential energy at 1 is 0, the kinetic energy is to be determined. Now, point 2 can be taken anywhere in the tank. I have told you so many times, the selection of the points will not make your question incorrect. The question will become incorrect only when you will write the incorrect value of the pressure energy or potential energy or kinetic energy. So normally we select the point 2, another point at the top of the reservoir. So can we say P2 gauge is equal to 0? Because again, the fluid is, the pressure of the fluid at the free surface is 0. Do you agree V2 will be equal to 0 because area of the tank is very large? Whenever the area of the tank or the reservoir is very large, the velocity will be taken as 0. Now the problem with Z2. So if you will write Z2 is equal to H1 plus H2, it means you have not considered the importance of multiple fluids. If it would have been a single fluid, then the height of point 2 from the reference line would have been the value of Z2. Hi Nitesh, welcome. So what is the value of Z2? Can anybody let me know what is the value of Z2? What is the potential energy head at point 2? One thing what we can do is convert this rho 2 in terms of rho 1. Convert rho 2 in terms of rho 1. How to convert one fluid column into another? If in manometry we study. So conversion of one fluid column into another giving the same pressure. So the height will be, can we write rho 2 into H2 upon rho 1? This will be the height. Yes, Paul, we have to write in terms of flowing fluid head. Why we are converting rho 2 into rho 1? Why we are converting rho 2 in terms of rho 1? Because we are supposed to write, whenever we talk about the Bernoulli equation, whenever we apply the Bernoulli equation, we need to apply the Bernoulli equation in terms of flowing fluid head. That is important. Why we are writing in terms of flowing fluid head? Because the velocity V1 will come out to be, the velocity head will be written V square by 2g. Whenever we will write V1 square by 2g velocity head, that is of the flowing fluid, which is rho 1. What is the flowing fluid? That is rho 1. Rho 1 is the flowing fluid. So we need to convert this rho 2 in terms of rho 1. Because we always write the energy conservation equation in terms of head of the flowing fluid. Do you guys understand? Yashpal. So the reverse will not give you the right result. Converting rho 1 into rho 2 will not give you the desired result. So we have to convert this rho 2 into rho 1, and in that case Z2, now Z2 will become as, then Z2 will be equal to the height H1 plus, then it will become rho 2 H2 by rho 1. If you apply the Bernoulli equation between 1 and 2 now, if you apply the Bernoulli equation between 1 and 2 in terms of flowing fluid, P2 by rho g, P2 by rho 1 g we are supposed to calculate. The Bernoulli equation in terms of flowing fluid is P by rho g plus Z plus V square by 2g is equal to constant. I hope you guys understand this. V square by 2g is equal to constant. Do you guys understand this? P by rho g plus Z plus V square by 2g. Now each and every term is in terms of flowing fluid. Each and every head must be in terms of flowing fluid. So because P2 is equal to 0, it does not matter whether we divide by rho 1g or rho 2g. Similarly, V2 is equal to 0, it does not matter whether we divide by rho 2g or rho 1g. The only parameter which matters is Z2, which is not 0. The potential energy which is not 0. So the potential energy head will be written in terms of rho 1 fluid. I hope this is clear. Because the orifice is kept in such a way that rho 1 is the flowing fluid. Or you could have taken, look, the point selection will not create a problem. P1 gauge is equal to 0, Z1 is equal to 0, V1 is unknown. You could have taken point 2 here. You could have taken point 2 here. It does not create a problem. So in that case, Z2 is equal to 0. V2 is equal to 0, but if we talk about P2, then P2 will be calculated by using the hydrostatic law. What is P2? We will write rho 2 g H2. I am writing gauge pressure. Rho 2 g H2. We are here. Now we are moving in downward direction. Rho 1 g H1. Now we need to find out the pressure head in terms of flowing fluid. So we need to divide here. The pressure will be divided by rho 1 g, not rho 2 g. If we divide by rho 1g, then g and g getting cancelled out. This rho 1 and rho 1 will also getting cancelled out. You will get the same result. Can you just let me know what is the result you are getting? You could have taken point here also at the interface. In that case, we need to take care of the potential energy as well as the pressure energy, because V3 is equal to 0 and Z3 we are not very much concerned, because it is between 2 and 3, between the reference line and point 3, it is only a single fluid which is having the density rho 1. So it is simply H1. Z3 is equal to H1. But if we write P3, so P3 will be rho 2 g H2, but we are interested in the head, pressure head in terms of flowing fluid. So we have to divide by rho 1 g, not rho 2 g. So P3 by rho 1 g will be equal to rho 2 H2 by rho 1. So always the Bernoulli equation must be written in terms of head of the flowing fluid. If you know this fact, or if you understand this concept, then you will never commit any mistake, even if there are 3 fluids, 4 fluids, 5 fluids, or any number of fluids. I hope this is clear. What is the answer to this one then? What is the answer? So V1 square by 2g is the only unknown on the left hand side. The right hand side, we can write it as 0 plus H1 plus rho 2 H2 by rho 1, isn't it? So V1 is given by under root 2g H1 plus rho 2 H2 upon rho 1. This will be the answer. Which of the given option matches with this? Which of the given options matches with this? Yes. Which option matches? Isn't it option B? Isn't it option B? So the option B is the right answer. I hope it is clear. Please give me yes or no. Only Yashpal is writing in the comment section. I want everyone to keep responding. I hope this is clear. Another important question is the question for a syringe problem. people get confused whether to use the momentum equation or energy equation. The next one is the syringe problem. The question says, the question says, find the force F. We need to calculate the force F required on the piston to discharge 1000 millimeter cube per second of water through the syringe shown in figure. 1000 millimeter cube per second. That is the discharge. We need to have the discharge 1000 millimeter cube per second through the syringe. Viscosity of the water is already given, and there are two questions, two parts, without considering the losses and considering the fully developed laminar flow in the needle. It means considering losses in needle. The second part is we need to find out the force without considering the losses. Another is considering the losses in the needle only, not the syringe. We are supposed to consider the losses in the needle. So let us talk about the first part, and before that let me tell you the flow is steady and uniform. Whether we analyze the flow in the syringe, or the needle, the flow is steady as well as the uniform, isn't it? The flow will be steady as well as uniform because the velocity V1 remains constant. And in the needle also V2 remains constant. It is not gradual change in velocity. So we can say local convective acceleration will be 0. Because there is no acceleration, so the change in momentum will be 0. Because there is no acceleration, momentum change will be 0. Do you agree or not? Rate of change of momentum or acceleration is 0, net force will be 0. So we cannot use, or we will not be going to use the momentum equation to analyze this. We will not use the momentum equation. So there is no momentum change or there is no acceleration. There is no acceleration. So net force must be 0. We will not use the momentum equation at all. So what we will do is we will draw the free body diagram of piston. We will draw the free body diagram of the piston and we will say net force on the piston will be 0. What are the various forces acting on the piston? One is the external force, F is acting on the piston. Another is the outside atmospheric pressure will exert a force. Another is the outside atmospheric pressure, that is PATM. Let me call the area of the piston as A1. The diameter D1 is given. Diameter of the piston or diameter of the cylinder is given. So area we can easily find out. So PATM into A1. And other than that, the inside fluid will also exert. Let me call the fluid pressure here to be P1. So fluid pressure will also exert a force in this direction. That is P1 into A1, isn't it? So if we draw the free body diagram and if we write the net force to be 0, so can we write F plus PATM into A1 is equal to P1 into A1, isn't it? Net force will be 0. Yes, Yashpal. So F will be equal to P1 minus PATM into A1. So this can be called as, because P1 is the absolute pressure here, because PATM is taken into consideration. P1 minus PATM is P1 gauge into A1, that is pi by 4 D1 square will be the value of force. This will be the value of force. Now our objective is to find out the value of P1 gauge pressure at 1. Now our objective is to find out the gauge pressure at 1. First of all, let us apply the continuity equation. If we apply the continuity equation, between, let me call this point to be 1 and here let me call this point to be 2. Point 2 is outside the needle, just outside the needle, and point 1 is in contact, the point 1 is in fluid which is in contact with the piston. So can we say A1 V1 is equal to A2 V2? So from here, diameter D1 is 10 mm, diameter D2 is 1 mm. D2 is 1 mm. So V2 or D1 square into V1 is equal to D2 square into V2. Put the value of D1 and D2. So we will get V2 is equal to 100 times of V1. Isn't it? V2 will become 100 times of V1. Yes, V2 is equal to 100 times of V1. And how to find out with the value of V1? We can easily find out the value of V1 by using the expression for discharge. Discharge is 1000 millimeter cube per second is equal to pi by 4 D1 square 10 square into V1. V1 will come out to be in millimeter per second. Can you find out the value of V1? Discharge is equal to area into velocity. So V1 is 0.0127 meter per second. In terms of meter per second, it will be 0.0127. And V2 will become 100 times of V1. So can we call it as 1.27? V2 is 100 times of V1. So now if we apply the Bernoulli equation between 1 and 2, if we write the Bernoulli equation between 1 and 2, write the Bernoulli equation. Why we are writing the Bernoulli equation? Because the losses are not taken into consideration in first case. So we can say P1 plus rho g Z1 plus rho V1 square by 2. Let me write the Bernoulli equation in terms of Pascal pressure. Rho V1 square by 2 is equal to P2 plus rho g Z2 plus rho V2 square by 2. Can you find out the value of P1 gauge? Z1 and Z2 are equal because both the points are in the same horizontal line. Z1 and Z2 will be equal because both are in the same horizontal line. So gauge pressure at 1 rho by 2 into V2 square minus V1 square. If you solve this correctly, rho is the density of water. If you solve this correctly, then you will get your answer to be 806 Pascal. Please do check and let me know. Are you guys getting 806 Pascal or not? Will you be getting 806 Pascal or not? And if we put in equation number 1, put the value in equation number 1, then F will be equal to, put in equation number 1, what was equation number 1? F is equal to P1 gauge into A1. A1 is pi by 4 D1 square. D1 is 10 mm. Convert it into meter. If you put all the parameter in their SI unit, if you put pressure as 806 Pascal, then your answer will be then your answer will be 0.06 Newton. I am giving you the concept, the calculation part you can do on your own. In the second part, considering the losses in the needle. So now we will write the energy equation in the second part. If we write the energy equation with loss in the needle. If we write the energy conservation equation, now we will not call it as Bernoulli equation. We will write the energy equation between 1 and 2. So P1 gauge will be equal to rho by 2, V2 square minus V1 square will be there, plus the loss in the needle will also be taken into consideration. This will be the expression. We will get this expression. This we have already calculated, 806 Pascal. Now HL in the needle, can we write F into L2, length of the needle, then V2 square, velocity in the needle, upon 2G D2, and the flow is laminar, so F is equal to 64 by Reynolds number in the needle. So 64 mu upon rho into V2 into D2. V2 into D2. Or you could have taken, sorry, it is not HL. If we write, then we could have written delta PL. My mistake. We could have written delta PL, pressure loss in the needle. And that can be written by using Hagen-Poiseuille equation. 32 mu V2 into L2 upon D2 square. This is Hagen-Poiseuille equation because the flow is laminar. 32 mu V2 into L2 into D2 square. Isn't it? So if you put the values, then you will get the answer. Or you could have, what you could have done is, you could have written delta PL in the needle to be HL in the needle is equal to delta PL by rho G, isn't it? So delta PL we are writing using the Hagen-Poiseuille equation. Or you could have written HL to be FL L2 V2 square upon 2G D2. For F is equal to 64 by RE. Both will give you the same result. If you want the accurate result, Yashpal, then you cannot ignore. You need to see whether the options are very close to each other or not. 100 times is not very large though. So better you should not ignore. It is always better if nothing is mentioned, you cannot ignore. You cannot say V1 is equal to 0. V1 cannot be 0 because it is not a reservoir. The area is not very large actually. Area is 100 times only. The area A1 is 100 times of A2. It cannot be considered as very large. Are you getting it? So if you will put the values, then P1 gauge 806 was already there. If you solve this, then it will come out to be 4064. So that will make it as gauge pressure at 1 will become 4870 Pascal. 4870 Pascal. That is P1 gauge. And if you put in equation number 1, if you put the value in equation number 1, then your answer will be, what is the answer? If you put the values in equation number 1, then the force will come out to be 0.38. 0.38 Newton. 0.38 Newton. Right? 0.38 Newton will be the answer. Let us move to the next question, and before that let us have an important information. There will be a national scholarship test for GATE exam going to be conducted on 25th of June at 9 AM in the morning. So based on your performance in the scholarship test, you will be able to get the various discounts in our paid courses. And moreover, you will understand your level of preparation, and accordingly you can plan your strategy or you can modify your strategy. So do join this, do attend this scholarship test. The registration is completely free and you can register yourself by the link given in description box. All right. Let us move to the next one then. Next question. The next question, this was asked in civil GATE PYQ. This was asked in civil engineering branch, GATE civil. And upward flow foil specific gravity is 0.8. So it means density is 800. Viscosity is also 0.8. It is not water. The flow is in upward direction. Takes place under laminar condition in an inclined pipe of 0.1 meter diameter as shown in figure. Right, the diameter is 0.1 meter. The pressure at section 1 and 2 are measured at 435. This is the value of P1, and pressure at 2 is 200 kilonewton per meter square. The units are in kilonewton per meter square or kilopascal. So the question is, to find out the discharge in the pipe. So what we need to do is, there are three methods. For laminar flow in a pipe, the flow is steady and uniform. Definitely the flow is steady plus uniform. There is no acceleration in the fluid. Total acceleration will be equal to 0. Whenever we analyze laminar flow or turbulent flow, we always assume the flow to be steady and uniform. We do not consider any type of acceleration in the flow, right? So the formula for discharge is equal to pi by 8 mu. If you remember the formula, delta PL by L into R to the power 4. R is the radius. What is the radius? Radius is 0.05. Radius is equal to 0.05 meter. And the problem, only thing people find difficulty in getting the value of delta PL correctly. This is section 1, this is section 2. So because the flow is from 1 to 2, then delta PL, it is called as piezometric pressure drop in the flow direction. So it will be P1 plus rho g Z1 minus P2 plus rho g Z2. If you will put the values correctly, if we take a reference line passing through 1, then Z1 will be taken as 0, but Z2 will be, what is Z2? Z2 is equal to, here Z2 is equal to 5 sine 45. If you will not commit this mistake, then only you will get the correct value for discharge. Are you getting it? Delta PL is always the piezometric pressure drop in the flow direction. When the pipe is horizontal, then it does not matter whether we find out the piezometric pressure difference or the static pressure difference. It does not matter. Whenever the pipe is horizontal, it never matters if we even find out the static pressure difference. But because the pipe is inclined, intentionally given as inclined, that is why the pressure difference delta P will not be the static pressure difference. It will be the piezometric pressure difference. If you will put the values correctly, then you will get the answer. Telegram link channel is already there here. Every time I keep on mentioning Arnav, but we cannot share the link in the chat box. In the comment section, we cannot mention the link. You either search me by Mechanical by Chandrasekhar on the Telegram, or this is the link. You can take the screenshot and you can type in the web browser, right? That is one method. Another method is either use the direct formula for laminar flow, or what you could have done is you could have used Hagen-Poiseuille equation. Delta PL is equal to 32 mu into V into L by D square, isn't it? But here also delta PL should be taken correctly. Delta PL should be taken correctly. If you put the value of delta PL correctly, then you will get the value of average velocity correct. What will be the average velocity? You will be getting the average velocity to be 16.19 meter per second. You will get the average velocity, and the discharge will be equal to pi by 4 d square into average velocity. Then you will get the answer 0.127. Or what you could have done is, the third step could have been by applying the energy equation with the losses. By applying the energy conservation equation with the losses. So we could have written P1 plus rho g Z1 plus rho V1 square by 2 is equal to P2 plus rho g Z2 plus rho V2 square by 2 plus delta PL. Again, delta PL is nothing but the piezometric pressure drop. Or you could have used like this, P1 by rho g, or you could have used the expression like this, P1 by rho g, then Z1, then V1 square by 2g, then P2 by rho g plus Z2 plus V2 square by 2G plus HL. You could have calculated HL. Then you will not commit mistake in Z2 and Z1. Z2 will be 5 sin 45. Isn't it? Z2 will be 5 sin 45. So you can find out HL. The value of HL will come out to be, the value of HL will come out to be, the value of HL will come out to be 26.408 meter. So either equate with FL Q square upon 12.1 D to the power 5. Here friction factor is 64 by Reynolds number. Or you could have equated with delta PL by rho G. Whatever method you feel comfortable with. F is equal to 64 by RE. So the discharge will come out to be 0.127. Whatever the method you select, if you will not commit any mistake, then you will get the answer as 0.127. And the second part of the question is, if the flow is reverse keeping the same discharge, if you get the incorrect value of discharge in the first part, then you will never get the right answer for the second part. And the pressure at section 1 is still maintained as 435. We need to find out the pressure at 2. So now again you can use the same formula. Q is equal to pi by 8 mu delta PL by L into R to the power 4. Isn't it? Discharge remains constant. What is delta PL here? Now delta PL will be P2 plus rho G Z2 because the flow is from 2 to 1. The flow is from 2 to 1. So in the direction of the flow, delta PL is the piezometric pressure drop in the direction of the flow. So delta PL will be P2 plus rho G Z2 minus P1 plus rho G Z1. Z1 is equal to 0, P1 is given, and we can easily find out the value of P2. If you will do the calculation correctly, then your answer will be option D. Then your answer will be option D. Or you could have used the another formula, delta PL is equal to 32 mu VL by D square. Here also delta PL is P2 plus rho G Z2 minus P1 plus rho G Z1. If you write delta PL correctly, then you will get the value of P2 correctly, because V will remain constant 16.19 meter per second. Why? Because there is no change in the discharge, only the direction of flow is reversed. There is no change in the discharge, there is no change in the diameter. So there cannot be any change in the velocity. Or you could have written HL is equal to 26.408 meter. There is no change in head loss even. That can be equated with FL V square by 2 GD or FL Q square upon 12.1 D to the power 5, or we can equate it delta PL by rho G. F is equal to 64 by RE. F is equal to 64 by Reynolds number. If you do this way, then you will get the answer for P2 as 614. And there is one more question I would like to share with you. This question was also asked in civil engineering in GATE paper. Beautiful question. From the multi-pipe system or compound pipe, there is a pipeline, diameter is 0.3 meter, length is 3 kilometer, carries water from point P to point R. This is point P, this is point R. The piezometric head at P is 100 meter and the piezometric head at R is 80 meter. These are the piezometric head at P and R, right? Now to increase the discharge, another pipe is added in parallel to the existing pipe from the point Q and R, between the points Q and R. So whenever we attach a parallel pipe, the discharge gets increased, that we all know. Whenever we attach a pipe in parallel to the existing pipe, the discharge in the pipe gets increased. And the length of the additional pipe is 2 kilometer and the distance between P and Q is 1 kilometer. So the original pipe length from P to R is 3 kilometer, P to Q is 1 kilometer and Q to R original pipe distance is 2 kilometer, right? And the additional pipe is also having the same length. friction factor to be assumed same for all the pipes and ignore the minor losses. Now the first part of the question says, what will be the percentage increase in the discharge if the additional pipe has the same diameter? So the additional pipe, diameter of additional pipe, this is, let us say, D1, this is D2. The diameter of the additional pipe is same as original existing pipe. I hope the question is clear. So we can say with additional pipe the new discharge is Q dash minus the original discharge without additional pipe of Q into 100. We need to calculate. First of all, find out Q. If we want to find out Q without additional pipe, there is a single pipe from P to R. This is point P, this is R, and the length is 3 km. And the piezometric head at P is 100. Piezometric head at R is 80. Without additional pipe, discharge is, let us say, Q. Discharge is Q. So if we write the energy equation between P and R, so we will write, let me assume the discharge to be Q here. So can we write piezometric head? So we can write PP by rho G plus ZP plus Vp square by 2G is equal to PR by rho G plus ZR plus VR square by 2G, isn't it? Plus the loss HL from P to R, frictional head loss. Vp and VR are equal because the flow is steady and uniform. There is no change in that area. There is no change in the discharge. So there should not be any change in the velocity. This is 100. This is 80. So we can say HL P to R. What is HL P to R? Can we write it as F then L P to R into Q square upon 12.1, then D to the power 5, D is already given, D is equal to 0.3 meter, is equal to 100 minus 80, that is 20. The loss will be 20. So if we put the value 0.04 into 3000 meter into Q square upon 12.1 into 0.3 to the power 5 is equal to 20, then you will get Q to be 0.07 meter cube per second. That is the discharge without the additional pipe. Good enough? That is the discharge without the additional pipe. Now with the additional pipe, now the new discharge will become Q dash, and because the length L1 is equal to L2, D1 is equal to D2. Let me write this way. The new discharge is Q dash. With additional pipe, the discharge is Q dash. Discharge is Q dash, and pipe 1 and 2 are parallel. Pipe 1 and 2 are parallel. So can we say HL1 is equal to HL2? And because L1 is equal to L2, D1 is equal to D2, and F1 is equal to F2. So from here we can say Q1 is equal to Q2 and each will be Q dash by 2. This is the special case of parallel pipe. Between Q and R there are two parallel pipe having the same length, same diameter and same friction factor. So the discharge will be equally distributed. Q dash by 2 will go here and Q dash by 2 will go here. Now if we write the energy equation again, between P and R, why we are writing the energy equation between P and R? Because at P the piezometric head is 100, at R piezometric head is 80. There is no change in the piezometric head between P and R. So what we will get is the loss HLP to R, which can be written as HLP to Q plus HLQ to R will be equal to, this will be equal to 20 meter. This is HLQ to R. Either we write HL1 or HL2. So can we write it as F into the length P to Q, Q dash square upon 12.1 into D to the power 5 plus F the length from Q to R into, it will be Q dash by 2 square upon 12.1, diameter is same, D to the power 5 is equal to 20. If you simplify this, So if you simplify this, your expression will be F is 0.04, 12.1 into 0.3 to the power 5. Then it will be length is 1000 meter, Q dash square, plus the second length is 2000 into Q dash square by 4 is equal to 20, isn't it? So the only unknown is Q dash. Now if you will find out Q dash 0.099, are you getting 0.099 something? You must be getting, please check and do let me know. You must be getting 0.099 meter cube per second. So we can easily find out Q dash minus Q upon Q into 100. So that is 0.099. It has increased 0.07 upon initial 0.07 into 100 will give you around 40. How much is that? It will be around 41.4%. That is the traditional approach. First of all, find out the discharge without additional pipe. First of all, find out the discharge without additional pipe, and then find out the discharge with the additional pipe, and then find out the difference or difference. Another approach could have been the shorter approach. Another short approach could have been, as the loss between P to R remains constant, whether we attach a parallel pipe or not, the loss remains constant, that is 20 meter. So can we say HL P to R in first case will be HL P to Q plus HL Q to R in second case? Isn't it? Loss will remain constant. Between P and R, loss will remain constant. So we can write F, the length P to R, then Q square upon 12.1, then D to the power 5 is equal to P to Q. Now the discharge will become Q dash square upon 12.1 D to the power 5, plus now for Q to R, F, the length is Q to R, then it will be Q dash by 2 square upon 12.1 D to the power 5. If you simplify this, the only concept here is the loss remains same. So with the single pipe and with the parallel pipe, the loss will not going to change, because energy is a point function. It does not depend on the path. Energy is a point function. So that is why the energy difference between P and R will still remain the same, whether we attach a parallel pipe or not. So friction factor will also get cancelled out from everywhere. Length of PR is 3 km is equal to length of PQ is 1 km plus length of QR is 2 km. So it will be 3Q square is equal to 1 plus 1 by 2, 3 by 2 Q dash square, isn't it? 3 and 3 are getting cancelled out. So can we say Q dash by Q is equal to root 2? If you are getting Q dash by Q is equal to root 2 and we are interested in Q dash minus Q upon Q, that is 1 minus, sorry, we are interested in Q dash by Q minus 1 into 100. So root 2 is equal to 1.414 minus 1, that is 0.414 into 100 is 41.4%. The percentage increase in discharge will be 41.4%. I hope this is clear. The second part is asking to find out the percentage maximum increase in discharge, which is theoretically possible. So we need to find out Q dash maximum by Q minus 1 into 100. What is the maximum discharge possible if there is no restriction on the diameter of the additional pipe? When D2 becomes infinite. Look, if D2 becomes infinite, then it will become reservoir. D2 becomes infinite, then we can say Q dash will become maximum, because the loss between Q to R will become 0. Loss between Q to R will become 0, or we can say, or the loss between P to Q will become maximum, that is 20. If D2 becomes infinite, it will become a reservoir, so there will be no loss. The loss will become 0 in Q to R. The loss will only be there in P to Q. So if we say HL P to R in first case is equal to HL P to Q plus HL Q to R in second case with D2 to be infinite, then this term will be 0. So we will write f Lp2r into q square upon 12.1 d to the power 5. Then it will be f into Lp2q into q dash maximum square upon 12.1 d to the power 5. If you simplify this, then these two terms will get cancelled out. Friction factor is same. So P2R is 3 q square is equal to P2Q is 1 into q dash maximum square. So from here q dash maximum by q will be root 3. That is 1.732. So q dash by q minus 1 is equal to 0.732 into 100 will be increase will be 73.2%. The maximum increase in discharge theoretically possible will be 73%. I hope this is clear. These are some wonderful questions where students have most of the doubts in analyzing. So that completes our session, guys. There are some sessions running on BYJU'S YouTube channel series, Super Saturdays, Knowing the Legends, Raftar series. So you can enjoy these sessions also. So see you in the next session. This is my email ID. You can join me on the Telegram, Mechanical by Chandrasekhar, if you are not a part of my Telegram channel yet. Acha, that's good, Arnam. So small steps every day will make you comfortable with the concepts. Even if you do not know the theory behind it, if you have understood, if you have attended the session, you have understood how I am solving the questions, you will get an idea. So it will always help. Knowing the knowledge or getting the knowledge is always beneficial. So with this note, let me take your leave. See you in the next class. Till then, enjoy, take care, have a good day and a great career ahead. Thank you very much, guys, for joining in. Jai Hind.